All right, video 2. People solve many different kinds of problems, and we're going to be talking about problem solving in this video. We have problem solving techniques for formulas and scientific facts. For example, you might need to know the formula for the area of a circle or how many protons oxygen contains. Other problems concern fitting things into a busy schedule or paying things for what we need. Solving problems involves a series of processes, including analyzing the problem, breaking it into component parts, and establishing goals. Intermediate goals address parts of the problem that must be solved to arrive at the terminal goal. And there are specific methods of problem solving that we're going to talk about today. An algorithm is a specific procedure that, when used properly and in the right circumstance, will always lead to the solution of a problem. Formulas are examples of algorithms. Many algorithms are more complex and time-consuming than simple formulas. One complex algorithm is called a systematic search. In a systematic search, each possible solution to a problem is tried and tested according to a set of rules. While algorithms are guaranteed to work, they're not always practicable, so in that case we would use a heuristic. And heuristics are rules of thumb that often but not always help us find the solution to a problem. They're like a shortcut. Heuristics are faster than algorithms, but they are not as reliable. Trial and error is simply exactly what it says. It's like systematic searching, but it's more haphazard and it's less reliable. But sometimes you have little choice but to resort to trial and error. Difference reduction, what you're going to do is identify your goal, where you are in relation to it, and the direction you must go to move closer to it. So in other words, you want to reduce the difference between your present situation, like the problem being unsolved, and your desired situation, which is the problem solved. The difference reduction method is a heuristic, and so it's not always reliable. Sometimes we think we've reached our goal when we haven't. And furthermore, sometimes we have to take what seems to be a step away from your goal in order to achieve that goal. A means-ends analysis, we know that certain things we can do, like means, will have certain results, like ends. As with the difference reduction method, means-ends analysis aims to reduce the difference between where we are and where we want to be, but the analysis method goes beyond difference reduction in its awareness, and a particular action will have a particular effect. Whereas difference reduction user is going to ask, what direction must I move in to get from here to there? The means-end analysis is going to say, what can I do to get there? With means-ends analysis, the problem is always broken down into parts, and then those little parts are solved individually and then put together. And we do this all the time without realizing it. Working backward is exactly what it says. It's related to means-ends analysis, but working backward involves breaking down a problem into parts and then dealing with each part individually. But the difference between working backward and means-ends is that the problem solver starts by examining the final goal, then works back from the goal to the present position to determine the best course of action. And it's particularly useful when we know what we want to accomplish, but we're not sure how best to begin. An analogy is a similarity between two or more items, events, or situations. And so when people have successfully solved one problem, we try to use the same approach in solving another problem that's similar. A mental set can be an obstacle to problem solving. And what this is, as we know from our discussion on problem solving by analogy, people often try to solve new problems in ways that work for similar problems, and the tendency to respond with a new problem with an approach that was already successful is called a mental set. But this can get in the way because we're not seeing, sometimes it's hard to see a new, more creative way to fix that problem. Functional fixedness is the tendency to think of an object as only being useful for the function that the object is usually used for. And we're going to do some examples for that. And this can also interfere with finding a solution to a problem. Flexibility is the ability to adapt to new, different, or changing situations, and this often leads to original thinking and creativity. Recombination is the mental rearrangement of elements in a problem. So all we're doing here is just kind of rearranging things to get a new perspective on them so we can try to figure out how to do them. Insight and incubation. Insight is that aha moment where you're like, oh, I finally got it. And the incubation effect is the tendency to arrive at a solution after a period of time away from the problem. And so the whole idea of, if you've got a problem that you can't figure out and you're going like, okay, I need to sleep on it. And then you wake up and you're like, okay, that's stepping away from the problem and then finding the solution to it while you're away from it. That's the incubation effect. And this is a picture of a chimpanzee this was an experiment that a psychologist named Kohler did. And what he did, the chimpanzee was placed in a room with some bananas hanging from the ceiling, and the chimp clearly wanted the bananas, tried to reach them by jumping, but he couldn't get them. So he walked around, looked at the bananas, walked around some more, noticed some boxes in the room, and sat down for a while. Then all of a sudden he got up, he stacked the boxes, and he climbed on them to reach the bananas. So he had suddenly seen the situation in a new way, meaning that he had had a flash of insight, and then the time that he spent sitting on the boxes staring at the banana, that's the incubation effect. And that's it. Thanks, guys.